And here again, we have a new problem on the screen, and the statement of the problem says a load suspended on a thread swinging in a vertical plane. Very good. At what angle of deflection alpha is the total acceleration of the load in extreme position? Extreme position. Okay. Is equal to the total acceleration when passing through the equilibrium position. You know, equilibrium position is always here. Yeah. An extreme position is something here. So, this is the extreme position, this is the equilibrium position. And there is an angle alpha, the required angle alpha. And the question asks that total acceleration of the load in the extreme position, and that means this position, should be equal to the total acceleration when passing through the equilibrium position. And as you know, at the maximum deviation from equilibrium, the velocity of the load is zero. Consequently, the normal acceleration also vanishes, becomes zero, normal acceleration, because it is v square by r. L in this case, v square by r. And if v is equal to 0, the normal acceleration, radial acceleration is 0. And the total acceleration, that means total acceleration is directed along the tangent to the trajectory. And in this case, there are two forces acting, tension and the force of gravity. And this angle is alpha. So tangential acceleration is simply this, that is mg sine alpha. Tangential force, not that acceleration. The force along the tangent is simply mg sine alpha. And I would like to write it 2 mg sine alpha by 2 cos alpha by 2 for a region, because I want to solve this problem, nothing else. And when passing through the equilibrium position, the velocity is maximum. And at this position, forces are acting in this direction, tension or gravity. These only two forces are acting. Both tensions are different. This T is something else and this T is will be different, I know. But velocity at this equilibrium position will be maximum. And the forces are acting radially. That means tangential acceleration is 0. And the normal acceleration is simply, suppose that here its speed is v, then the normal acceleration will be simply equal to v square by L. M is a bad choice, v square by L. So that total force in radial direction will be mv square by L. But normal acceleration is simply v square by L. L is the length of the thread. And we will now relate the velocity when passing the equilibrium position and the extreme position. And to do so, we need to use the law of conservation of mechanical energy. So I think this height is nothing but this is L cos alpha, and this total length is L, so this length is L minus L cos alpha, that is equal to L1 minus cos alpha, this length. And शुरू में कहाँ था, यहाँ से छोड़ा था कि यहाँ से छोड़ा था, यहाँ से वेलोसिटी देके छोड़ा होगा या फिर यहाँ से, उससे कोई फर्क नहीं पड़ता इस क्वेश्चन को, नो मैटर व्हाट. सो मैं इसको रिवर्स करके भी लिख दूँ या नहीं भी लिखूँ तो भी चलेगा. मैकेनिकल एनर्जी कंजर्वेशन मीन्स हाफ एम बी स्क्वायर इक्वल्स एम जी एल into 1 minus cos alpha, mgh. And loss at the loss of this much kinetic energy, it gained this much of potential energy. And you would like to write, मैं trigonometry कुछ लिखना चाहूँगा, that will be 2 mgl sine square alpha by 2. Isn't it correct? Of course it is. 1 minus cos alpha is 2 sine square alpha by 2. So I wrote something like that. And then, so that I can equate both of them. This is our this equation and this equation. I would like to equate the forces, and this is one force and velocity mv square by L. mv square I can get from here. By L I will arrange these things, mv square upon L. Yeah, L gets cancelled out. L gets, so here 1L is left. Oh, this is 2 mgl sine square alpha by 2, sine square alpha by 2. Who wrote this? I did this. This was completely wrong, man. I was telling it right, but writing all incorrect things. This was 2 mgl sine square alpha by 2. And this is the thing. So that mv square mv square by L becomes 4 mg sine square alpha by 2. And this is fine. This is basically our, this should be our equation number 2, so that I can equate both 1 and 2. And 1 was 2 mg sine alpha by 2 cos alpha by 2, sine alpha by 2 cos alpha by 2, and equation 2 is 4 mg sine square alpha by 2. And this was the requirement of the problem, so we needed to equate them, and you can get the values of alpha. I guess you will get tan alpha, and tan alpha you will get, that will be tan alpha by 2 you will get, and I think you will get tan alpha by 2 equals 1 by 2, so that alpha becomes 2 tan inverse 1 by 2, and this should be your answer. And this is the answer, I know it. Thank you very much for watching, and look for the next few problems, क्योंकि वो problems कहीं और से नहीं आए हैं. They have come directly from the book of Berkshire and Kirby and Berkshire. So they are special. So look for them. Thank you very much.